videos. So I've received this question. It's a very interesting question, and this is about combinatorics. So those who are from 5 students or those who study A-level statistics, just give a try and just pause the video and try to do this question. Okay, now after you have computed the value, you're supposed to be able to find the probability to this question, right? So before talking about the probability, we want to try to analyze this question first. So you and 2 friends intend to write letters to each other. So each person writes 1 letter. So 3 letters are then shuffled. So one of the 3 people chooses 1 letter randomly. So either the person would choose his or her own letter, or the letter from his friends or his or her friends. Okay, so find the number of ways such that each person must receive no his or her letter, which means you cannot, for example, if person A, B, and C writes letter 1, 2, and 3, so person A must not receive letter 1, so person B must not also receive letter 2, and person C must not receive letter number 3. Okay, so we're gonna try to think the total possible combinations, because this is actually about random arrangement. Actually, if you try to imagine this situation, you can just use the first method, which is this 3 factorial equals to 6. This is the total one. The second one you would try to use is you try to draw a row and column diagram, which includes, for example, you have letter 1, letter 2, letter 3 for the person A, and person B, letter 1, letter 2, letter 3, and this gives also for C. You try to use another color, a pen of another color, try to connect them. So 1 must go to 2. You cannot repeat the number, because this represents that the person A has chosen letter number 1. Okay, so 1 goes to 2, and then 2 goes to 3, because person B has chosen letter B, so you cannot go to 1 or 2. Or another case, person 1 so still chooses A, and then person B chooses number 3, and then person C chooses number 2. So look at the second one. So person A chooses the letter number 2, so 1. Okay, let's say person B chooses number 1, and then person C then chooses number 3. Okay, and then person A still chooses number 2, but this time person B chooses number 3, person C chooses number 1. And then in the same manner, you will have for each case, okay, the red case has 2, and then the blue case has 2, and then the last case, let's say any color case like yellow, will have also 2 cases. So in total, you must have 6 cases, 6 arrangement. We try to analyze the numbers. We try to use the letters again. We try to record out, try to lay out the numbers. So for the dark red one, you will have 1, 2, 3, and then the lighter one, you will have 1, 3, 2, and then for the case 2, which is the green one, you have 2, 1, and then 3, then 2, 3, 1, and then you have 3, 1, 2, and then 3, 2, 1. So from left to right, well, on the left side must be person A, person B, and then to the right, person C. Person A, person B, person C, person A, person B, person C. So we must ensure that person A must receive no letter from his own, which is the letter 1. So the letter 1, which is the number 1, okay, this combination will be cancelled, and this combination will also be cancelled. And then we must ensure that person B must receive no letter 2, okay, which is this one. And then we must ensure that person C must receive no letter 3. So this one cancelled out. And hence, what we have left is 2, 3, 1, and 3, 1, 2. So in total, we have 2 cases where each person receives no his or her own letter. Okay? So what is the probability of getting such condition, such event? So the probability equals to 2/6, which is 1/3. That's all.